right, Jamison, can you hear me okay? You may have to unmute your microphone icon. The top left of GoToMeeting.
Hello.
There you go. Now I can hear you. Yep, you got to do that very first thing whenever you log in to GoToMeeting, is you got to unmute that microphone.
Right.
They force a mute on everybody as the default setting.
Mm-hmm.
So, all right. So what are we doing tonight?
Let's see. Sorry, I should have been more prepared than I am at the moment.
Okay. Take your time.
Okay, awesome. I grabbed my history book instead of my math book. 1 sec.
Huh?
All right. Looks like we're starting with writing exponential functions.
Okay. Do you have some problems?
Yeah.
Or a review sheet or something?
Yeah, I've got this math book here that I'm going to be working out of.
Okay.
All right, so it says write an exponential function whose graph passes through the given points, and the points are 1, 3,
Okay.
and 2, 12.
Okay. So assuming we're looking at an exponential function like that, so it's saying one of the points is 1, 3, and another point is 2, 12. Okay. What's the general format? Let me make sure I got the record option on here. Oh, gosh, hold on a second. Yeah, I do. Okay. What is the general format for an exponential function?
Y equals ABX, or AB raised to X, yeah.
And they told us that it goes through the point 1, 3, and it also goes through the point 2, 12.
Yes.
Now, and the beautiful thing about exponential functions is you can solve for A quite easily. Well, hold on a second. Let me think about this for a second. Well, let's substitute in our 2 points. So that's going to give us 2 equations, right?
Yes.
The first equation we can write based on this point.
3 equals AB1.
3 equals AB.
Oh, okay.
What's the next equation we can write?
12 equals AB?
Well, in this case, it's not AB, it's AB to the 2. In other words, x is 2 here. X was 1 in the first case.
Okay.
Okay? So, between these two equations, we can solve the problem. If 3 equals AB, what is, solve for one of those variables. Let's solve for B. What's B equal to?
It could be 3, maybe?
No, solve it algebraically, just like you would an equation. You got 3 equal AB. What is B equal to? You're going to divide both sides by A.
Oh, okay.
So B equals 3 over A.
Okay.
Now that we know B equals 3 over A, we can attack the second equation. Well, we still don't know what A is, but we know that B is 3 over A. We're going to square that. You get where I'm going here? So now we got 12 equals A times 9 over A squared. Well, that A cancels with the squared. And now we have A equals 9 divided by 12. You see how I get to there?
Mm-hmm.
So A equals 3/4. Well, let's go back to the simplest equation we have, which is this one, where B was equal to 3 over A. And if A equals 3/4, then B equals 3 divided by 3/4, which is 4. So we got A equal to 3/4, B equal to 4. So our equation would be y equals what?
3 over 4 times 4.
No, yes, my apologies. 3 over 4 times 4, but we still got to raise it to the x power because it's an exponential.
Right. Okay.
In other words, when you have your general equation, and once you solve for A and B based on these 2 points, now you have your specific equation. So this specific equation is that exponential that I just wrote at the bottom left.
Mm-hmm.
And let's see if that, before we leave the problem, it's worthwhile just checking one of the points. When x is equal to 1, this point right there, well, then we have y equals 3/4 times 4, which is 3. So that point checks out. When we have x equal to 2, then we have y equals 3/4 times 4 squared, which is 3/4 of 16, which is 12. So that point checks out. Once you get 2 points that check out, you're done.
Okay.
Okay. Now, okay. Now I guess I'm thinking of another kind of problem. There's usually, you don't need 2 points on these. You can usually figure out A or B just based on the fact that B to any power is 1. So a lot of times they won't tell you 2 points on the curve. It'll just maybe give you the y-intercept or something. And then you can solve for A if you have the y-intercept. And once you solve for A, you can, I think, solve for B. I don't know. You got another one?
Yes.
Try it on some real problems here. So, that other technique.
Did you want another one of these problems?
Whatever problem you want to go over, Jameson, it's your time to tell me the problems you need help on.
Okay.
Don't give me a problem you know how to do. Give me one you're not sure how to do.
Fair enough. Start a new page. All right. What's our time, by the way? Because
5 to 5:30, so we got about 15 minutes.
Okay, that's what I thought. Because I booked half an hour, but then the confirmation email said an hour, so I wasn't sure what happened.
Really? Those confirmation emails can be messed up every now and then.
All right. We have a condense the expression problem.
Okay.
And we're dealing with logs again. So it's 3 log sub 7 times 4.
Okay, let me tell you how to pronounce that.
Okay.
3 times log base 7 of 4.
Okay.
Not times. I'm not multiplying log sub 7 times 4. This is more like a function. In other words, if I said pronounce that, you would say f of x. It's not f times x.
Got it.
Okay?
All right. And then minus log sub 7 of 8. Right?
Log base 7.
Log base 7, sorry.
Yeah, you can say sub. I don't know. Is that what your teacher says, is sub? Or does she say base?
She says base, but I've heard other...
Yeah, sub works, but base is the more common terminology.
Okay.
Okay? So, we've got 3 log rules. Do you remember what they are?
Not at the moment.
Well, let me write them over here.
Okay.
Log of 2 things multiplied together equals the log of the first thing plus the log of the second thing, much like exponents. And in fact, logs are exponents.
Okay.
Okay? That's rule number 1. Rule number 2 is when you're dividing in the argument. If I have A divided by B, what's that going to equal?
Log A minus log B.
Yeah, you always do, but one level less mathematically. In other words,
Okay.
if I'm multiplying in the argument, I'm adding. If I'm dividing in the argument, I'm subtracting. And if I am exponentiating in the argument, like that, then I am multiplying. Multiplication being one step less than exponentiation.
Okay.
The key thing here is, and this rule number 3 is the most important one. There's a lot of calculus problems that have to use rule number 3. That's the only way they can be proven.
Okay.
Okay. So these 3 rules are your primary rules that are going to govern all of your condensing and expanding. Now, they want you to condense. Why do I know? Because they have 2 different log expressions. So these rules, you got to know how to go from left to right, and you got to know how to go from right to left.
Okay.
Okay. Well, I'm looking at something over there that looks similar to what we have. So I know my final expression is probably going to be the log of something divided by something else. In other words, I'm going to pull this down to 1 log expression.
Okay.
Okay. But the order to go when you are condensing is usually start with 3 and then work your way up. So how can I rewrite that? If rule number 3 is true, how would that be rewritten? In other words, you're going from this b times log of a, the log of a to the b power.
Would it be added to the 4?
Not added. Where's that b right there? An exponent.
Oh, okay, so would it be log base 7 of 4 raised to the 3rd?
Yeah.
Okay.
True.
I got mixed up. I thought the 4 was an exponent, so.
Oh, I see why, because I got it written a little high. Yeah.
Yeah, it's a little.
Yeah. Okay, so that is that. And then we're still subtracting log base 7 of 8.
Mm-hmm.
And now apply rule number 2. Or if it was addition, in other words, we no longer have anything multiplying the log in front.
Mm-hmm.
We've got everything down to log and this. So what does this turn into? A single log expression. And these rules only work, incidentally, if the base is the same.
Okay.
If one base is 7 and the other base is 6, I can't do anything with it. But if it's the same base, all three of these rules over here assume the base of whatever. It can be whatever you want, but it's got to be consistent on the left and the right side of the equation. So, what am I going to do to the argument? What's going to happen in the argument?
Are we going to apply the 3 to the 4?
Not yet. We don't need to yet.
Oh, would it be 4 cubed over 8?
There you go.
Okay.
Now, 4 cubed is 64, and the whole thing becomes log base 7 of 64 divided by 8, which is just 8. So that's the final answer.
All right.
Which is interesting. That means this must be 2 log base 7 of 8. Right? Has to be.
Yeah.
And it is. In other words, 8 squared is the same as 4 cubed. So those two expressions actually are correct. It'd be easier to do if they gave us 2 log 7 base 8 minus 1 log 7 base 8 has to be 1 log 7 base 8. But they mixed it up just enough on us that we had to use these 3 rules. Okay? Now, I'm going to leave those rules there just to give you a chance to make sure you got them memorized.
Okay.
And then I'll take them away and we'll do some without. Just remember that when you're multiplying in the argument, you're adding. When you're dividing in the argument, you're subtracting. And when you're exponentiating in the argument, you are multiplying.
Okay.
So, give me another one. We can go either way. You can condense or expand. They will ask you an equal number of questions on each. If you have a test and they have 4 expands, they'll have 4 condensed.
Right.
Would you find one to expand if you can? That's just probably an easier place to start than condensing. I can make some up if you want.
That would probably be good.
Tell me what this is. Doesn't look like any of those rules, does it?
No.
What are factors of 6?
2.
Not 2. 2 times 3.
Oh, okay.
Okay. Now you can use rule 1. What's that going to be?
Log of 2 minus or plus log of
minus or plus. Yeah. If I am multiplying, it's plus.
Yeah.
And you can now you could have gotten that off your calculator also, but it shows you what you can do with logs. In other words, I can factor 6 and turn it into this.
Mm-hmm.
And that would be the answer that they would.
Oh, okay.
Okay. And all right, go ahead and give me some more. I don't want to make them up because that may be way off in degree of difficulty that your teacher is using.
All right. Why don't we do another condensed then?
Okay, that's fine.
All right. We got 2 log of 5. Plus log of 4.
Okay, what's the first step?
To apply one of the rules.
Always start at the log. Actually, whenever you see a coefficient in front of the log, start with rule 3.
Okay. Yeah,
That's
right.
the one that deals with coefficients. There's your coefficient right there.
Mm-hmm.
In front of the log. So we're going to move it to its exponential position. So how can I rewrite this?
Log of 5 squared.
I'm going to go ahead and write log of 25. Okay?
Oh, okay. Okay.
Just to shorten it. Yeah, it is log of 5 squared, but
right.
Plus log of 4. What's that equal to? Keep condensing until you get one log expression.
Log of 25 over 4, or 25 times 4?
Which is the log of 100.
Okay.
Okay? Now that actually can be condensed further. Notice that this is base 10. So what is the log of 100? Excuse me, what is the log base 10 of 100? And if you don't know what that is, let's introduce a variable. I'm going to say that's x. Now the way to solve that is to turn it into an exponential expression. Give me this as an exponential expression. All log expressions can be written exponentially, and all exponential expressions can be written logarithmically.
Okay.
They're just two ways of expressing the same thing. It's just there's an advantage in logs in that you get to use all these rules over here.
Mm-hmm.
But you got to know how to change that into an exponential expression. What are logs? What's the definition of a log? They are exponents.
Okay.
So what's the exponent in my exponential expression going to be?
The log?
No, logs are exponents, r being the equal sign. So x is going to be my exponent.
Okay.
Okay? What's my base? 10 to the x power equals what's in the middle. The way to look at it is the number on the far left raised to the power of the number or variable on the far right equals the argument. What's in the middle? Okay? Now it's easy to solve. You can solve that in your head. 10 to what power is equal to 100?
10.
Nope.
No.
Still there? Still there? Having audio difficulties here, Jameson.
Yes.
10 squared is 100.
Having a little bit of...
Can you hear
Alright, can you hear me now?
Can you hear me?
Yeah, sorry about that.
10 squared is 100, right? 10 times 10 is 100.
Yeah.
So x is 2. So let's get rid of the x and write in there 2. So that whole thing comes down to the number 2 because it came down to log base 10 of 100. And we can figure out what log base 10 of 100 is. It's 2.
Mm-hmm.
Because 10 squared equals 100.
Okay.
Okay? You want to do one more, or You have to go? I got time to do one more if you want.
Yeah, sure.
Okay. These are really important. You're not going to get through a log course without these 3 rules. That's what logs are all about.
Do you think we should
Is
do another
memorizing
log
those
one?
3 rules. What?
Do you think we should do another log one?
Yeah, I do. Well, what else you got? I mean, it depends on what else you got. Is there something else you don't understand that you'd like to get cleared up? Logs is a pretty big subject. Usually I spend about an hour with people on logs because you not only have these log rules over here, you not only have expansion and condensation, but then you have solving log equations.
Yeah.
You have a log equation to solve. That'd be the best thing for us to do.
Log equation.
Yeah, you have an equation that's got logs in it. In other words, it's got to have an equal sign in it to make it an equation, and there's got to be logs on some part of it.
Yeah, I have one.
Okay, what is it?
Log base 4 of 4x plus 7. Equals log base 4 of 11x.
Yeah, this is actually pretty easy. This is not really what I meant, but well, you're not really going to be dividing both sides by log of 4. That's not what's happening. But if I say the log base 4 of one quantity is equal to the log base 4 of another quantity, then I can make the leap to say 4x plus 7 has to be equal to 11x.
Okay.
Now if I solve that, I get 7x equals 7, x equal 1.
Okay.
Okay. And then you want to check your log equations. Log equations are notorious for giving you 2 solutions. In other words, this ends up being a quadratics. You know, it's a more complicated problem. You get a quadratic. Quadratic gives you 2 solutions. Almost invariably, one of those solutions violates the domain. You got to throw it out. Okay? What is the domain? All arguments have to be greater than 0. You can't have 0 in an argument, and you can't have negative numbers.
Right.
It's like if I said, what's the domain of that? Well, x has to be greater than or equal to 0. X can be 0. You can take the square root of 0. But if I said, what's the domain of this? X has to be greater than 0. You cannot take the log of 0.
Okay.
Okay? So that should help. Yeah, this is based on the principle that if you're doing one, you know what I'm saying? It's kind of like the following. If I said to you, e to the 3x equals e to the 4x minus 1, well, there's nothing special here. They're both e's. That means that has to be equal to that.
Okay.
Okay? And that's all you're doing in that problem there.
Okay.
All right. Let's end it there. And I'll let you go. And yeah, set up some sessions. Logs can be a little confusing to people.
Yeah.
The thing you have to really keep in mind is that all exponential expressions like this can be expressed logarithmically. How would you logarithmically express that? First of all, logs are what? Logs are exponents.
Exponents.
Not much of it. Now, we've got to figure out where the 2 goes and where the 8 goes.
Would it be log base 2?
There you go. That's always b, right? So that's
yeah.
So that's how you convert from one to the other. Now, if I wanted to go from this one back to this, I would take the number on the far left, raise it to this power, and that's equal to 8, which is what that says.
Right.
So that's how you go back and forth. You really need to be able, Most log problems, you have to be able to go back and forth between exponential and logs in order to be able to solve
Right.
them. Okay. All right. Jameson, you have a good rest of your evening, and I'll talk
Thank
to you
you.
next time.
All right. Talk to you next time.
All right. Bye-bye.
Bye.